Pingo. For other uses, see Pingo, disambiguation. Pingos are intrapermafrost ice-cored hills, 370 m, 10 to 30 foot, high and 31,000 m, 98.3,281 foot, in diameter. They are typically conical in shape and grow and persist only in permafrost environments, such as the Arctic and subarctic. A pingo is a periglacial landform, which is defined as a non-glacial landform or process linked to colder climates. It is estimated that there are more than 11,000 pingos on Earth, with the Tuktoy-Aktuk Peninsula area having the greatest concentration at a total of 1,350. There is currently remarkably limited data on pingos. History edit. Collapsed pingo in the Mackenzie Delta. The outline of the previously drained lake can be seen. August 8, 1987. In 1825, John Franklin made the earliest description of a pingo when he climbed a small pingo on Ellis Island in the Mackenzie Delta. However, it was in 1938 that the term pingo was first borrowed from the Inuvialuit by the Arctic botanist Alf Erling Porsild in his paper on earth mounds of the western Arctic coast of Canada and Alaska. Porsild Pingo in Tuktoy-Aktuk is named in his honor. The term pingo, which in Inuvialuktun means conical hill, has now been accepted as a scientific term in English language literature. Formation edit. Main article, Permafrost. Pingos can only form in a permafrost environment. Evidence of collapsed pingos in an area suggests that there was once permafrost. Pingos can collapse due to the melting of the supporting ice and give rise to a depression in the landscape showing an inverse shape, horizontal mirror. Hydrostatic pingos edit. Closed systems, also known as hydrostatic pingos, are formed as a result of hydrostatic pressure that has built up within the core of pingos due to water. They occur in regions of continuous permafrost where there is an impermeable ground layer. These pingos are found in flat, poorly drained areas with limited groundwater available such as shallow lakes and river deltas. The formation of these landforms occurs when layers of permafrost generate an upwards movement or pressure, resulting in masses of confined soil freezing, which pushes material upwards due to expansion. The figure above illustrates this process and the changes that occur throughout the year. This type of closed system pingos is formed in an area where a lake has been infilled with sediment. This indicates that the ground is insulated, allowing liquid water to collect underneath the sediment. In winter months this sediment begins to freeze, which leads to expansion of sediment, confining the water and increasing the pressure. This results in the formation of a mound due to the upwards pressure. However, during summer months the ice core of the pingo begins to melt, which causes the mound to cave in. Hydraulic pingos edit. Hydraulic, open system, pingos result from groundwater flowing from an outside source, i.e. subpermafrost or intrapermafrost aquifers. Hydrostatic pressure initializes the formation of the ice core as water is pushed up and subsequently freezes. Open system pingos have no limitations to the amount of water available unless the aquifers freeze. They often occur at the base of slopes and are commonly known as Greenland type. The groundwater is put under artesian pressure and forces the ground up as it makes an expanding ice core. It is not the artesian pressure itself that forces the ground up, but rather the ice core that is being fed the water from the aquifer. These are often formed in a thin, discontinuous permafrost. These conditions allow an ice core to form, but also provide it with a supply of artesian groundwater. If water pressure entering an artesian pingo is strong enough, it can lift the pingo up, allowing a sub-pingo water lens to form underneath. However, if the water lens starts to leak water, it can cause subsidence, which can compromise the structure. These pingos are often oval or oblong shaped. It is still not entirely understood why open system or hydraulic pingos normally occur in unglaciated terrain. Pingos usually grow only a couple of centimeters per year, with the Biak pingo growing at a rate of 2 cm, 0.79 in, a year, and the largest take decades or even centuries to form. The process that creates pingos is believed to be closely related to frost heaving. The base of the pingo tends to reach its maximum diameter in its early youth. This means pingos tend to grow higher rather than growing in diameter and height at the same time. The height of pingos can range anywhere from 3 to 70 m, 9.8 to 229.7 feet, and their diameters range from 30 to 1000 m, 98 to 3281 foot. The shape of pingos is usually circular. Smaller pingos tend to have curved tops, whereas larger pingos usually have collapsed mountains or craters due to the melting of exposed ice. Locations edit. Greenland edit. The landscape of Greenland contains many pingos and other glacial landforms. In western Greenland it is estimated that there are 29 pingos, whilst in eastern Greenland it is estimated there are 71 pingos. The majority of pingos in Greenland are located within Disko Bay and Nuussuaq Peninsula within western Greenland, as well as some in eastern Greenland in Mestersvig. The thickness of the permafrost at Disko Bay is around 150 m, 490 feet, deep, providing for ideal conditions for the development of closed-system pingos. There are 20 pingos located on Disko Island, with the largest located on Kugongak alluvial plain at 100 m, 330 foot, wide and 15 m, 49 feet, high. In eastern Greenland, pingos are found in Neo-Alfjordsfjorden. They are well known because they are the northernmost pingos of eastern Greenland. The largest of these pingos is 100 m, 330 foot, wide and 8 m, 26 feet, high, taking the shape of a semicircle. This pingo is still active, meaning it is increasing in elevation over time. Canada edit. Tuktoyaktuk Peninsula pingos edit. Mackenzie Delta with drained lake, foreground, ice wedge polygons, and a growing pingo, August 1987. Pingo in the Mackenzie Delta area. The Tuktoyaktuk Peninsula is an area with a marine tundra environment on the shores of the Arctic Ocean in the Northwest Territories, Canada. This peninsula is covered in thick permafrost, which is known to be more than 50,000 years old. There are many pingos within the Pingo Canadian landmark area, all ranging in size and diameter. The most well-known pingo in this area is Ibiuk Pingo, which is the tallest pingo in Canada. The height of this pingo is 50 m, 160 feet, above sea level, but the pingo is still increasing in height by a few centimeters every year. This pingo is one of the younger pingos in the area, estimated at around 1,000 years old. Since about 1990, several larger pingos have started to melt out as the injection ice of the core is exposed. Alaska edit. Approximately 80% of Alaska is covered in permafrost, with 29% of this continuous permafrost, 35% discontinuous permafrost and the rest sporadic or isolated permafrost. Throughout Alaska, there are more than 1,500 known pingos, with the majority being open system pingos. The height of pingos in Alaska ranges from 3 to 54 m, 9.8 to 177.2 feet, in height and 15 to 450 m, 49 to 1,476 feet, in width. The world's tallest pingo is located in Alaska, known as the Kadlurashillik Pingo. The Kadlurashillik Pingo is 54 m, 177 feet, in height, but is continuing to rise in elevation by a few centimeters a year. Siberia edit. In Siberia, an area containing a high density of close-system pingos can be found near Yakutsk, located on the Lena River. In this area there are more than 500 pingos next to the Lena River. The area consists of alluvial plains areas of thick permafrost, allowing pingos to form and develop. Central Asia edit. Areas of Central Asia are known to have pingos at the highest elevations in the world. For example, the Tibetan Plateau has pingos at above 4,000 m, 13,000 feet, in elevation due to its permanently frozen terrain. This environment is perfect for pingo production, and the cold, dry permafrost along with cold temperatures deters pingo collapse. Scandinavia edit. Despite its high latitude and the occurrence of permafrost, no modern pingos are known from Scandinavia. Palsa Mountains in Scandinavia have been mistaken for pingos. Some depressions found in Jutland, and some circular lakes in the Finnmarksvidda plateau may be remnants of collapsed pingos. The possible Jutland pingos could have developed during the Wakeselian glaciation and the possible Finnmarksvidda pingos during cold periods of the last deglaciation. Mars edit. Although no pingos have been confirmed to be located on Mars, scholars agree that there are indisputable signs of pingo-like features, PLFs. PLFs are periglacial features which have been discovered but are usually not classed as pingos. This is usually because they are not large enough to be classified as pingos, or there is not enough evidence to class them as pingos. Effects of climate change edit. Global warming is causing Arctic temperatures to rapidly rise, causing permafrost to thaw. For this reason, permafrost environments are extremely vulnerable to climate change in the Arctic. Permafrost degradation caused by climate warming is indicated by increased mean annual ground temperature, increased active layer thickness, talc and thermokarst development and disappearance of permafrost islands. The interchange between permafrost degradation and aggradation shapes subarctic and Arctic lowland landscapes, and therefore contain records of past climate and landscape development. Pingos are vulnerable to surface disturbance given the considerable amount of ground ice stored within them. Abrupt permafrost thaw processes can cause ice wedges within pingos to melt, which can result in increased pingo collapse and the formation of remnant lakes. However, there are currently few studies investigating how climate change could affect formation and growth of pingos. See also edit. 1. Gas hydrate pingo, submarine dome structure formed by the accumulation of gas hydrates under the seafloor that resembles a pingo. 2. Cryovolcano, type of volcano that erupts volatiles such as water, ammonia, or methane, instead of molten rock. 3. Frost heaving, upwards swelling of soil during freezing. 4. Kettle, landform, depression or hole in an outwash plain formed by retreating glaciers or draining floodwaters. Some are known as pingo ponds, especially in Norfolk, England. 5. Laccolith, mass of igneous rock formed from magma. 6. Palsa, a low, often oval, frost heave occurring in polar and subpolar climates, a low oval elevation in areas with permafrost, frequently peat bogs, where a perennial ice lens has developed within the soil. 7. Periglacial lake bordering a glacier or ice sheet. References edit. 1. Jump up to. Pidworny, M. 2006. Periglacial processes and landforms. Fundamentals of Physical Geography. 2. Jump up to. McKay, J. Ross, October 2, 2002. Pingo growth and collapse, Tuktoyaktuk Peninsula area, Western Arctic coast, Canada, a long-term field study. Geography Physique et Quaternaire. 52, 3271-323 doi 10.7202/004847 ARISSN 1492-143X. 3. Jump up to. Harris, Stuart A., 1988. Glossary of Permafrost and Related Ground Ice Terms. ISBN 0-660-12540-4. OCLC 20504505. 4. Gross, G., Jones, B.M., 2011. Spatial Distribution of Pingos in Northern Asia. The Cryosphere. 5, 11333. Bibcode 2011 T-Cry, 5, 13G. doi 10.5194/TC5-13-2011. 5. Jump up to. McKay, J. Ross, 1998. Pingo growth and collapse, Tuktoyaktuk Peninsula area, Western Arctic coast, Canada, a long-term field study, PDF. Geography Physique et Quaternaire. 52, 3. University of Montreal, 311. doi 10.7202/004847 AR retrieved June 23, 2012. 6. Jump up to. McKay, Ross, 2011. Pingos of the Tuktoyaktuk Peninsula area, Northwest Territories. Geography Physique et Quaternaire. 33 Department of Geography University of British Columbia, 361. doi 10.7202/10003222AR. 7. Jump Up To. McKay, J. Ross, January 1, 1988. The Birth and Growth of Porcilled Pingo, Tuktoy Aktuk Peninsula, District of Mackenzie. Arctic. 41, 4. doi 10.14430/Arctic1731. ISSN 1923-1245. 86 Bizarre landforms created by global warming. New Scientist. Retrieved November 9, 2022. 9. Jump Up To. Yoshikawa, K. 2013. Pingos. Treatise on Geomorphology. 8, 274-297. doi 10.1016/B978-0-12374739-6.00212-8. ISBN 9780080885223. 10. Jump Up To. Formation of Closed System Pingos. Retrieved April 25, 2020. 11 Pingo Canadian Landmark. Archived from the original on June 3, 2007. 12 Yoshikawa, K. Nakamura, T. Igarashi, Y. 1996. Growth and Collapse History of Pingos, Kyugonguk, Disco Island, Greenland. Polarforskung. 64, 3109-113. 13 Benuk, O. 1998. Pingos at Neo-Alfjordsfjorden, Eastern North Greenland. Geology of Greenland Survey Bulletin. 180, 159-162. doi 10.34194/gub.v180.5101. 14. Jump Up To. Jorgensen, M.T., Yoshikawa, K., Kanofsky, M., Schur, Y., Romanovsky, V., Marchenko, S., Gross, G., Brown, J., Jones, B., 2008. Permafrost Characteristics in Alaska. Proceedings of the 9th International Conference on Permafrost. 3, 121-122. 15 Holmes, G.W., Hopkins, D.M., Foster, H.L., 1968. Pingos in Central Alaska. U.S. Government Printing Office, 140. 16. Jump Up To. Burr, D.M., Tanaka, K.L., Yoshikawa, K. 2009. Pingos on Earth and Mars. Planetary and Space Science. 57, 5541-555. Bibcode 2009 P&SS. 57541B doi 10.1016/J.PSS.2008.11.003. 17 Svensson, Harold, 1976. Pingo Problems in the Scandinavian Countries. Byuladin Periglakjalny. 26, 3340. 18. Schur, Edward A. G., Abbott, Benjamin, November 30, 2011. High Risk of Permafrost Thaw. Nature. 480, 7375 3233 doi 10.1038/480032A. ISSN 0028-0836. PMID 22129707. S2CID 441-2175. 19 Cheng, Qiudong, Wu, Tunghua, June 8, 2007. Responses of Permafrost to Climate Change and Their Environmental Significance, Qinghai Tibet Plateau. Journal of Geophysical Research. 112, F2F02S03. Bibcode 2007 JGRF 112.2S03C. CITES IRCS 10.1.1.730.9627. doi 10.1029/2006 JF000631. ISSN 0148-0227. 20 Wetterick, Sebastian, Schurmeister, Lutz, Nazarova, Larissa, Polagushkina, Olga, Bobrov, Anatoly, Pagosian, Lilith, Savlieva, Larissa, Syrykh, Lyudmila, Mathis, Heyrun, Fritz, Michael, Gunter, Frank, July 2018. Holocene thermokarst and Pingo development in the Kolyma lowland, NE Siberia, PDF. Permafrost and periglacial processes. 29, 3182-198. Bibcode 2018 PPPR. 29182 W doi 10.1002/PPP.1979. S2 CID 135299374. 21 Gross, G. Jones, B.M., January 7, 2011. Spatial distribution of pingos in Northern Asia. The Cryosphere. 5, 11333. Bibcode 2011 T-Cry, 5, 13G. doi 10.5194/TC5-13-2011. ISSN 1994-0424. 22 Ponds and Pingos. Norfolk Wildlife Trust. Retrieved April 7, 2021. Bibliography Edit. 1 Easterbrook, O'Neill, G. Finn, 2010, and O'Neill, W. Scott. 1999, Surface Processes and Landforms. 2nd edition. 1999, 1993. Prentice Hall, Inc. p. 412-416. 2 Burr, Devon M., Tanaka, Kenneth L., Yoshikawa, Kenji, 2009. Pingos on Earth and Mars. Planetary and Space Science. 57, 565-41-555. Bibcode 2009 P&SS. 57 541b doi 10.1016/J.PSS.2008.11.003. ISSN 0032-0633. External links Edit. 1 National Snow and Ice Data Center, NSIDC. All about frozen ground, how does it affect land? Archived from the original on December 18, 2010. Retrieved December 29, 2010. 1v2. T3. E. Periglacial environment. Landforms.